Hello friends, welcome back to Civil3D Pro Tips and Tricks YouTube channel. We are getting so many requests from young engineer, college pass out and who are using first time Civil3D that they want to learn intersection modeling from the scratch. So here we are starting a new series where we are going to model various type of intersection, T intersection, Foley intersection, roundabout, and then globally complex intersections. And we are going to catch up various techniques, various scenario, various cases to cover everything. So here we are starting this series from very basic T intersection. So first get start what you require to model corridor T intersection in Civil 3D. Well, any corridor, when you model, you need first the basic thing is to have alignment, profile, and the cross section. So this is the most basic things you need to model any corridor. Without this, you cannot build any corridor in Civil 3D. Once you have all these three things, second thing you need to divide it into the region. Well, the reason is that your intersection is a part of the various sections, and you cannot model everything into one. You have to divide it because of the geometry. Like this is my normal straight section, and this is my cross sections. So you have to divide, and also it will be vary with like the cross section. Once you have a footway or curve, or you have something different. So in that way, the corridor will be divided into small region and it become an entire corridor for the junctions. So second thing you need to have decide your region, and then you have a target. Well, the target is that everything you cannot build with the normal assembly, like in case this curve return assembly here you can see I have a varying width. So if I have to model this, I cannot model with the 3.6 normal assembly or normal cross section. This is varying width. So in this scenario, what I need to have the targets. So in this area, I have to have a horizontal target. So it could connect to this edges, and also vertical target because I have to connect with the level. So it will be a smooth connection. So that will comes into the target part, and then the target would be anything. For the horizontal target, you can take the polyline, 3D polyline, feature line, or even alignment. And for the vertical target, I mean the level target, one is the horizontal, other is the level target. You can have a 3D polyline, feature line, and profile. And the third thing is the surface target, that you need to connect this to existing surface with some slope, and where you can give just surface target. So you need to have understanding of this basic things to create your corridor. Like you should have this three things first ready with you: alignment, profile, and cross section. Then you need to decide the reason. I mean, how you're going to model this. You need to divide into small segment. You decide those. Then you decide the targets. How you going to target? What do you have to give it to the target? If you don't, you need to create some targets. So once you have all this, then it all the compromise to your one corridor. So we are going to see how we can do all those things. Well, let's start with the alignments first things. So here I have three regions. For this, I have a center line. So I can simply design this region with my alignment profile. I have a center line alignment, and I already designed the profile for this. What I need to have just a cross section to design a model this bit of region. So let's go one by one. So first I do this bit of thing region. So I have alignment profile. Now I have to have a cross section for this. This is the third requirement. So I'll go to the corridor, and the cross section is called assembly in Civil 3D. So I create assembly, And what I do, I'll give some sensible name to it. So I'll go with, this is my alignment for the road A, so I'll give it to road A assembly. So I'll just give road A, click here, and then I have a lane on the both side will be a 3.5 meter. So I'll go here on the plate, I'll click this tool platers, and I select lane superposition AOR, and click here and here. Then I can change this assembly as per my requirement. So my lane width is 3.5 and my cross slope is 2.5%. So I'll go select both these two, go to the properties here and change as per my requirement 3.5 and slope 2.5. And then I have all these things to model this bit of part. So I'll go to the corridor and go to the create corridor. Now here I'll give the name of the corridor road A, and select my baseline type, which should be alignment and profile. So I select my road A alignment. This is road A. Then I decide my proposed profile. I still select my proposed profile and I select my assembly. So you could have a this thing. Just click OK, and now here it will become. So this will be a one region already, which is this region, and you have to decide changes for this. So this region will start from change this. So I click. So you can click select your changes from here as well. So you select, click over here, and it will be give you option to select from where to where you have to model your this region. So I select this start and end changes, and I'll just give apply and rebuild the corridor, and it will be rebuild my corridor as you can see. So this is my corridor. What I can do, let's see in the 3D. So I divide my viewport into two, and from here I just rotate these things, and you can see this is my 3D corridor. So this is just a normal corridor because I haven't taken anything curb or footway. So this is also one of the point with the experience I can tell. Whenever you're designing any corridor, always start with the lanes only. So first you create all lanes, create the alignment, profile, and everything finalized. Then you need to start modeling into detail. Then you start this adding curves and footways and everything, because then your level and everything will be finalized, so it will be easy for you later on just to model it very detailed rather than from beginning. So always start with the basic corridor, start with just lanes, finalize your alignment, profile, and everything, then go into the detail. So this is, you can, from here you can see conceptual stage, and you can see the corridor. Okay, so you can see creating this into 3D as well. So I created this region. The next thing I need to do is to add surface. The reason I'm adding surface to it, like the top surface, because I need to design this alignment and profile, and for this profile I need to connect to the existing here as well as this proposed, and for this I need a label. So when I create surface for this, it will give me some labels which I can add to this my corner radius alignment, so it will be connected on the both end, so you can get the smooth profile. So what I go to the corridor, and in the surface I select this, create corridor surface, and I give it to name that I'm building top surface, and from here code you can enter the top and give it to overhang top links, and always give your corridor to boundaries. So in go to the boundaries, click here, right click here, and give this corridor extend as the outer boundary, and let me give some style to surface so it will be visible, and click OK. So you could see now the contours are visible. So this is my proposed surface for this bit of region. Now I have to design the alignment and profile for this. So always a trick that when you're designing alignment for this corner radius, always give some overlapping area. So overlapping on this existing, overlapping on this proposed, so you can catch up the slope as well as level for this. And it will be easy for you to design the smooth profile going from this to this. So let's first design alignment. Now you can design the alignment by using the alignment from polyline method or using alignment by layout method. There is also third method which is called connected alignment, which we're going to see in the later in more detail. So let's start with the basic things. So here I'm going with the alignment, create alignment with the layout options, and just give it to name. This will be on here north side. So I'll give it to north, road A, 01, and click OK. And from here, I'll choose the option tangent with curves. So I start here from here to get some overlapping section. So you can catch up slope and the level of existing, and click here. Same way I choose up to here to get some overlapping section. Now I just extend this line to get proper PI points. So I extend bit of line to create proper alignment. Add this, and from here you can change your radius anytime you want. So I'll give my radius to 15 to match section. So this is my alignment is ready of this side. Same way I do for the another. I go to create alignment, layout, and this is the south side. So south, road A, 01, click OK, then start tangent with curve options. Again, some overlapping area with the existing, then here, and again some overlapping area for the proposed. And again, I extend this line to get exact PI points. Okay, and from here I can change my radius to 15. Okay, so I design my profile for it. Now what I'll do, I select my, oh sorry, I design my alignment. Now I design my profile for it. I go here, the 2D, go on top, and now I select my alignment. Once you select your alignment, you get some options over here. On the ribbon bar, you select surface profile. Here you can add those surfaces into it. So I add my ground surface and my top surface of that bit. To match my profile in the both end, I select any style for this, draw profile view, and here. So to smoothly connect into this both side, I have to connect here to this here. So now I design my profile from layout. So I have to have proposed profile which is connect on the both end, and also carry the slopes, and click OK. So I'll go here, I choose select fixed line. So from this to this, it will be follow existing slope and level, this bit of area, and from here it will be follow my proposed area, length and slope, and in between there will be a profile for this. So I'll go here, vertical curve, and now it is asking me to select first entity, which is this, and the next entity, which is this, and the pass through point, and I click OK. So this is way I design my profile for this. Then same thing I need to do this for this alignment. Go to surface profile again, add those existing and proposed ground, change the style so you can recognize which is existing and proposed. Select this. Again up to this, you can see here that I have to fall up to this to the ground, and from this point it should be a proposed slope and level. So again go to the profile, from layout, again start fixed tangent line, so it will be follow this section, and then up to this it will be follow this section. Okay, and then you need a curve in between. Now here is a bit tricky to give the curves simple curve. From here what I'll do, I'll select some floating curve, select this, and give some k value, like give minimum 3, and here same thing. Now I do free vertical curve from here to here, and I use pass through point, and connect this. So I have a profile for this. Now the reason I use this floating curve and this point, that I should have a continuous profile, smooth profile, so there shouldn't be any kink. There should be a free smooth profile. So that's why I use the floating curve and then free vertical curve, so it will be a continuous smooth profile. Now you have all the requirement, alignment and profile for this. Next thing, the third requirement is the cross section or assembly. So let's build the assembly for this. Now you have to select check your alignment direction for this. So my 0 is here and 35 years alignment is going in this direction. So if I have to model this bit of region, I have to have my lane on this side. It will be a right side. So I go to create assembly, and this will be a road A right side. Click OK and click here, and from this tool palette I'll add the lane assembly on the right side. Delete this one. Now here the slope and the width doesn't matter because this will be uh, governed by the targets, as this is not a typical slope, sorry, same slope and same width everywhere. It will be varying. So the slope on this will be vary, slope of here will be vary, same way the length width will be vary. So in this scenario, it will be the slope and the width will be gone by the target. So we are not worrying about this. And here for this bit of reason, it is going from this 0 is here, 50 is here, is going in this direction, so it will be on left side. So I create another assembly and give it to road A left. Select this and select on the left side. Same thing. This doesn't matter because it will be governed by this levels and alignment or profile, because it will be a varying, it's a varying slope and the varying width, so it will be governed by the target. So I've done this more. So I have my alignment profile and cross section is the ready. I know this my reason B and C. The next thing I have to have a target. So let's see what I have for the target. So once I have to target in this up to this line to the existing, so it will be connect to the existing road smoothly, and it should be connect to the my proposed alignment as well. So for this, I need to have a alignment and the profile target, horizontal vertical target on this region and as well as this region. So in this part, I have my center line alignment and its profile to target. So I have target on this side, and in this side I need to have some targets. So this is the existing, I don't have any alignment and profile for that. So next thing what you need to have a horizontal and vertical target is you can either do it with the feature line or 3D polyline. For the horizontal, and for the vertical you can do the 3D line and feature line. So I will use the feature line which will be satisfy both my horizontal and vertical target requirement. So let's build one feature line. So you can design the feature line with two options. Either you can create feature line from scratch, or you can convert any polyline into the feature line. So what I can do, I go to create feature line options, click OK. You can give any name to this feature line like existing road. So I give it to existing road H. Then it to connect and click OK. Select my first point and the second point. Enter, enter. Now I need to give this feature line to existing ground level. So I go select my feature line, go to elevation editor, and from here I select those 2 points, and here there is option for this surface. So I click this and choose my existing ground surface to give the existing label, and I choose this option insert intermediate grade breakpoint. So wherever the ground in existing road the levels are changing, it will be cover those area. So click OK and enter, and you can see, so from here to here the levels are changing. I click OK. So now I have a horizontal and the vertical target on this side also. So I can able to build this region and this region. So again I go to the corridor, and now in corridor I would add this two region. For that I need to add the baseline. So first thing I need to add my alignment, which is called baseline. So I have this north alignment and it's a design profile for the north alignment. Same for the south one. So I select my south road and the south road profile for this. Third thing, it's required to have cross section. So right click and call add region. So this is the north on the right side. So you have to select appropriate assembly for that. And the left side, this is done, this is done. Next thing, you need to add the targets like I said. So you go to over here and you need to have horizontal and vertical target. So you first go with the horizontal. So in this bit of area I have feature line as a horizontal target. I select this and then I go to the alignment because on this side I have alignment as a target. So I select my alignment, click OK and add. So this is done. I selected my horizontal target. Now next thing I will go with my vertical target. So first thing it go with the feature line. So the feature line has both horizontal vertical. And then I choose with the profile option. I select my road A and its design profile. Select OK. Click OK. So I've done the targeting for this. Same thing I need to target for this south section. Again go there, select road A and then the feature line, select feature line. And then for road A's profile and then changing from here to select my feature line. As you can see here, it gives you different option to select feature line, survey figure or 3D polyline, and you can change from here to select the profile. Okay, so you have to mind this one, two options. Click OK and you're done. Now next thing you need to select from up to where this region will run. So you have to select your chain edges. So from south, it will be start from this end because this overlapping area we have just taken to get the slope and level of the existing end both. So we are not modeling this bit of region, we are just modeling this region. So we will select, decide chain edges for that. So we just model that bit of area and go here and select this. So we have decided start and end area for both. And now the next thing is to have a frequency. Let's click OK and see the frequency things. So yep, it's done. So now you can see that it couldn't model properly. So there bit of area and because of this is the frequency. The reason is that when you uh, model a corridor and if you go to the frequency tab, it will show you that it plays the assembly at 10-10 meter interval on the curve part. So because it will be 10-10 meter interval, it's not cover entire area. So what you need to do at the curve location, you could have a small frequency like 0.5 meter. Okay, the same thing I'll go here and 0.5 and apply, and you can see now it modeled properly all the region. So and now it is connecting. So now you can see it will be connecting to my slope over here. As you can see the both contours are matching. I'll just delete this hatching. You can see it properly connecting to my proposed road section and it's connecting to my existing road, and you can see it is into the 3D. Okay, Now still there are some corner left out. What you can do, uh, select your corridor, and from here also you can change. So you go to the edit frequency, select your region, and here you can add more extra sessions. So up to this point, because it's not connecting here, click OK and click OK and enter. So now it's connecting to it. The same thing you can do it over here. So in somewhere you can see, because it is placing on zero point 0.5 meter interval, some corner will left out. For that you can add extra frequency for that. So this way you can model your normal T junction. Once you model this, then you can add the curve to your assemblies. So I'll go over here and go to curves, and I can add urban gutter to subassembly here and here. Okay, here on this side, on outer side, and here on this outer side. Okay, once you did it, just you need to rebuild, and it will be model your curve as well. Then you can add sidewalk to it. So adding. So once you model the basic, you can anytime do into detail. You can add curve and footway after that. All you need to do is just rebuild. So you can add anything after that and just go and rebuild. So you can see now it is have my footway. Then you can anytime change your section. So suppose if I have to change this bit of width, so I can go and select similar assemblies. Okay, and then from properties I can modify sidewalk width to 2.5, and just again rebuild. Alright, so it's done. Next thing you can add uh, daylight point and surface target. So I go to the basic and select my basic side slope cut and ditch. Select this and select this. Okay, and then just go and select from properties. It will be cut slope 3:1, fill slope 3:1, and in cut section, if there is a cut section, you can create swell to it. So this is a swell thing. All right, the same you can add. You just copy this assembly and you can place this into another assembly as well. Okay, and same way I can copy this into another assembly as well. So in this way I can build my detailed assemblies once I model with the basic. Now this thing, once you added this cut and fill slope, what you need to add to a surface target. So once I rebuild this, it wouldn't show until I add the targets. So I go to here, select my corridor, and from here I go with the edit target. I click this. Now here I select my region where I have to edit the target. So click this. Here I have to add the surfaces. So I select my original ground and original ground and click this. So you can see that I got surface target. Same thing I need to check select another region, click OK. Okay, same thing here. and click OK, and this is done. Okay, so now I'm doing it in more detail. So if any case you want to see this into 3D, just let's select corridor, right click and go to the object viewer, and you can see. Okay, so this is your detail corridor. You have a roads, footway, and the earthwork slope. So this way you can uh, model your normal T intersections, and the next time we model the same T intersection with the existing but with the different method. We will going to use offset alignment and connected alignment method, which I'm going to show you in the next video. So keep watching our channel. Thank you for watching this.